Hello, everyone. Welcome to this jointly hosted webinar by Paladion, MicroFocus, and Aberdeen on application security at the speed of DevOps. Our speakers today are Derek Brink, VP and Research Fellow at Aberdeen, Vinod Vasudevan, Chief Technology Officer at Paladion, and James Rabon, Senior Product Manager from MicroFocus. Before we get started, if you have any questions for the Q&A session, please submit them using the Questions tab under your Slides window. You can also download this presentation from Attachments. You just need to click on the Attachments tab below the video screen to get your copy. This webinar is being recorded. All attendees will receive a link to the webcast along with a copy of the ebook Application Security at the Speed of DevOps in a few days. It's my pleasure to welcome your first speaker, Derek Brink.
All right, thank you. Hi, everyone. This is Derek Brink. I'm with Aberdeen Group and based outside of Boston. So my role here is to start things off and basically lay a foundation for the discussion. I'll begin with some trends, some findings from Aberdeen's ongoing research, and then as we go along, we'll get more detailed as we talk with Vinod and James. App security at the speed of DevOps, really the starting point I want to make has to do with traditional challenges in application development and the shift in approach to application development that's happening, and why that creates an opportunity for improved security and reduced risk if we have the right approach to those things. So that's the thesis for this first section here. This is the trending stuff that application security traditionally in the traditional waterfall approach to the software development lifecycle has been on the outside trying to get in, basically. The traditional waterfall approach has had phases of analysis, design, implementation, testing, release, deployment, and then ongoing support and updates. Those are phases that are typically carried out sequentially over a period of many months. In my career, which is longer than I care to admit now, sometimes many months has been 18 months, even longer for software release cycles. That is not how things happen today, but in that traditional approach, it tends to reinforce organizational separations between the different teams. So architects, developers, testers, ops, support, security, they're all kind of separated and makes collaboration amongst those teams difficult. So that's sort of the status quo of the way things have been traditionally. And so what we see in response to that is a shift. We see a shift towards rapid application delivery methods. I'm using that term kind of as an umbrella to cover things like Agile and also DevOps. Recently DevOps movement has really been growing. And it's just got a dramatically different approach to development of apps. It emphasizes communication and collaboration across the different parts of the life cycle. It emphasizes tighter integration across design and development and testing and production and so on. So the basic idea behind rapid application development approaches is to respond more effectively and more quickly to customer needs and to market opportunities by making a lot of small changes really fast, as opposed to by making a large collection of changes on a fixed and lengthy release schedule. So the emphasis is on faster time to market and very heavily on a focus on delivering customer value. Those are the biggest drivers. There's big opportunities too, improve security and reduce risk, as we've already said, given that you have the right security architecture and the right process and the right kind of collaboration. So just some more quick background. I think it's important and interesting to see where we've come from. It's one of those overnight success stories. It's really been, a half century in the making. The roots of the traditional waterfall approach really go back, as far as I know, maybe some of you can correct me if I'm mistaken, but it goes back as far as 1970 when there were some reactions to traditional waterfall approaches to project management. Those were viewed as, these are some of the criticisms, overly sequential in terms of the schedule. We've already talked about that. Overly rigid in terms of requirements. You don't even start the project until you've negotiated and fully defined all the requirements between, in my past, I've been a product manager, so we had to negotiate with engineering to talk about what are the requirements. and generally inflexible. Once created, the requirements and the schedules are really hard to change. And so those issues make it hard to balance. There's always conflicting business objectives in development projects. You want to deliver, of course, high quality and highly complex capabilities, but at the same time, you've got to meet schedule, stay within a budget, and adapt to changing market needs. So these are, kind of flaws or difficulties of the approach. And with respect to schedule, it's kind of ironic. This is a chart that comes from my research. This happens to be 250 respondents who are predominantly waterfall in their approach to development. And we just simply asked them the question, what % of your projects are late? And you can see the dots there on the curve represent basically a histogram, and you kind of make a curve out of that histogram. It falls kind of nicely a ski slope looking shape. It's very common. And if you kind of take a statistical glance at this, the median would be 10%. So half the time, that's what the median refers to, of course, half the time it's 10% or less of the projects are late, but the other half, up to 60% of projects are late. That's a long tail of risk, as it were. And so that's the irony of this. With the focus on schedule, up to 60% of the time, you don't meet your goal. Here's another evolution in this around 2001. So it's surprising that if you think about it, it's been 15 years plus ago the Agile Manifesto came out, and it aims to address this issue, and it placed higher value. It placed value on different things. So it values individuals and interactions over processes and tools. This comes straight from the manifesto. If you haven't seen it, it's kind of fun to look at that. It values working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a strict plan. And so the basic ideas are just launch with a minimum viable product that is, use shorter development cycles or sprints to deliver features, and frequently reassess and optimize so you can give continuous value over time. And it requires, of course, very close collaboration of teams that are carried across multiple functions. And so you really need this real-time collaboration in application development, and that's even been amplified more by the widespread adoption. The teams have used virtualization and cloud services, which just makes this need to real-time collaboration even greater. We spin up new capabilities on virtual systems much more quickly and flexibly than in the past. And so again, from Aberdeen's research, it just confirms these trends that the shift is very strong towards rapid application delivery methods, whether it's Agile or DevOps. You can see on the scale here, if your eyes are good, on the right is 100% Agile, on the left is 100% Waterfall, and then there's different stages in between, and you can see the shift is over to the right. In fact, if you compute to sort of Net Promoter Score style, if you're in marketing, you know the Net Promoter. If you're plus 100%, it would be everybody's shifted to Agile. If you're minus 100%, it would be everybody's over on Waterfall. And this works out to be plus 64. So generally, if it's more than 50%, it's an indicator of really strong in that direction. And this is even stronger than that. It's plus 64% have moved away from the traditional waterfall approach to adopt these rapid application delivery methods, whether it's Agile or DevOps. So the shift is definitely here. It's confirmed in the research that we see. This is another question from the research that I used to create this graph. It was really, what do you place value on? So in terms of rank order, it's just highlighting the difference. The plan-driven waterfall type approach in the reddish color there emphasizes schedule above other things. That's the highest priority. It's a highly structured use of resources to deliver a committed set of features, otherwise known as requirements, on a carefully defined schedule. So schedule first, and then resources and features, and then market response is obviously still a priority, but it's lowest of the four. The value-driven approach, exemplified by Agile and DevOps, is opposite in the sense that it places the highest emphasis on value. So it emphasizes the highly flexible use of resources for rapid and sequential delivery of features in response to changing market needs. So the emphasis in the purple section there is on the value-driven response to the market, still balancing resources and features, and giving less emphasis to schedule. So this is based on the research, but I just thought it was a visually stark comparison of one approach to the other. And when we ask questions about drivers, why are you investing in this? You can see some of the reasons here. The number one is to make developers more productive. Second one down is to increase leverage of the kind of infrastructure that we're using, virtualization and cloud services, and you can read on from there. But there's also things on the side in the margin there that I highlighted that we have a lot more complexity now in the development environments, and we're getting positive results from this value-driven approach. So, for example, more than 80% of the organizations in our study have a portfolio of 50 or more applications to run their business. And again, using that sort of Net Promoter Inspired Index, net plus 75% indicate that they've had an increase in the total number of lines of application code that are being supported. So a much more complex environment. And it actually, bears out that if you compare one group to the other, the primarily agile group as compared to the primarily waterfall group are realizing a significant improvement in costs and a significant improvement in not just for development, but also in the total project cost, which includes not just development, but also ongoing support and operations. And you can see in the middle there that reducing security-related risks was actually a middling, sort of a modest driver for investment in rapid application delivery initiatives. And done right, it can be a key outcome as well, and that's the point of the webinar here today. So what are some characteristics that we see in the research? If you look at rapid application delivery and some of the capabilities and characteristics of those teams, that gives you a blueprint for what application security needs to look like. So I'll kind of go through this kind of quickly. The first point is on this chart. This is a traditional waterfall approach. It really just desperately needs to adapt to be effective. The old approach was had an explicit testing phase. You can see in the yellowish bar chart that more than a third of the defects were found during that explicit testing phase, and also 20% of defects were found after deployment and post-release. So that just hasn't been working that well. Web applications, for example, we know have been the leading cause of confirmed data breaches. We see that in the Verizon Data Breach Investigation Report series, for example. 7 times more effective than all other attack vectors. And under rapid application delivery, with this emphasis on faster, more frequent cycles, this kind of approach, this kind of find it and fix it later, after deployment approach, just doesn't really work. It can only get worse. In fact, it can't get any better. So we need to change from that. So I've got 4 quick examples, just looking at characteristics of what application security should look like. Those are the 4 areas. Let's just go ahead and talk about them one by one. In terms of modeling security threats, it needs to be changed from singular and upfront, kind of a upfront one-time thing, to continuous. So 45% of respondents in our study do threat modeling. The 27% more plan to do that. So it's just under half, but you can see some good growth there. And if you're going to fit in with that approach, then threat modeling should be integrated into the planning for every iteration and every sprint, and carried out with quick design tools as opposed to through formal and lengthy, documented type processes. That's a quick change. In terms of integrating and testing, there's a bunch of capabilities. You can see here the dark part of the bar is current, stacked on top of that, and sort of the hashed format is planned in the next 12 months. So you can see integration and testing is predominantly manual now. 2/3 of it is automated, but the other third plan to implement that in the next year. You can see things like testing occurs with every iteration, code is designed to support testing, those kind of things. So if we're going to support security within this kind of approach, we need to be automated by design, we need to be iterative and continuous with security, and we need to be trackable using the same systems as the other kind of work in progress, right? So if there's defects that need to be addressed, they need to be tracked in the same defect tracking systems. Collaboration needs to be done early and often and sharply focused on value. You can peruse all these slides and read an ebook at the end to get the detail. I'll just kind of highlight the things on the right margin. If you're going to fit in the rapid application delivery approach to collaboration, characteristics show what application security needs to look like. It needs to describe security requirements in terms of customer value, just like every other bit of functionality. It's not about technical details of how bad things could happen. It needs to be presented in terms of why is it valuable to the customer. and we need to participate in we meaning the security teams, need to participate in the planning and throughout all the successive iteration reviews, the same as every other stakeholder, not after the fact, as we were talking about before. In terms of communication, it needs to be predominantly direct and real time. So you can see, again, characteristics in terms of everybody's holding cross-functional team meetings, they're using chat tools and collaboration platforms. Training is the least likely on the far right, but if you're going to fit in with these approach, you can see a big jump in the intent for that over the next year. If you're going to fit in with this approach to communication, then application security needs to integrate seamlessly with direct and real-time methods that are being used. So meetings, chat tools, collaboration platforms needs to integrate with those. And it just looks like you can see here that it'd be a priority to accelerate cross-functional training here. It's currently only being done by 2 out of 5 participants, but also, strong growth intended in the next year. And so this kind of to wrap up, there's some selected capabilities to look for. I've kind of grouped them into the development side and the operations side. So again, those characteristics give us a blueprint for how the approach to security technologies and practices need to adapt. So let's just kind of look at those. On the development side, we should automate application security scans. This is by design, ideally based on triggers embedded in the code itself. If the results of those scans shouldn't just be thrown over the wall and hope that developers may get to it later, right? That's the old Waterfall approach. We want to integrate them into the standard defect tracking system and do that in an automated way. If you're talking about operations, we want to have a security architecture that's purpose-built for this environment. So we want to collect and respond to configurations and events related to security. And remember that this is a predominantly cloud-based development and deployment environment. And just to do that, you'll hear more about this from the subsequent speakers. It's just a very rich and complex set of technologies. So there's integrated development environments, there's build servers, there's defect tracking systems and communication platforms, reporting systems, APIs involved. So a lot of technical detail in saying that. It's easy for me to write, but you'll hear from Vinod and James about how that actually happens. In terms of operations, we need to remember deployment needs to be automated too to the leading cloud service providers, whether it's AWS or Azure, and using the standard provisioning, configuration, and orchestration tools, which could be Chef, Puppet, Ansible, or what have you. And so that leads me just to sum up here. Again, this is the platform, and the others will build on this. Rapid application delivery is designed to respond to needs and opportunities more quickly, as opposed to the traditional waterfall approach. It's really value-driven as opposed to plan and schedule-driven. If you're going to reduce risk, it's a great opportunity. It was a modest driver for investment, but if you have the right architecture and process and collaboration, it can actually be a great outcome. We've got a number of things having to do with how security technologies and practices can adapt, from modeling, integration, and testing, describing requirements in terms of customer value. This is user stories is a typical phrase used for that. Active participation by the security team throughout the process, integration with all the many ways to collaborate and communicate, and cross-functional leadership by the security team to accelerate the priority given to security throughout the process. And lastly here, some capabilities, technical capabilities. You want to automate scans, automate publishing of results in the defect tracking. You talked about that purpose-built architecture and the automated deployment kind of capabilities. So again, I'll just say that what we did is just look at the characteristics of the teams, and use that to say this is what solutions should look like. It probably won't be a surprise that the solutions you'll hear about represent those kind of things and more. There is more research. Here's how to communicate with me if you want to. And for now, I'll just hand it off to Vinod, and I'll be here at the end for questions as well. So Vinod, thanks for the opportunity to make that intro, and I'll hand it off to you.
Thanks, Derek. Hello, everyone. I'm Vinod Vasudevan, co-founder and CTO of Paladion. I'll start with the software development journey. We heard this from Derek as well. Software development has evolved from waterfall to CI/CD or continuous integration and continuous delivery model. Over the next 15 minutes, I will cover how to integrate security into the CI/CD model, look at some of the implementation models around some of the key concepts that Derek covered. Before we understand security in CI/CD, let's take a quick look at how security was integrated in the Waterfall world. Waterfall methodology was linear, with each phase executed one after the other. Mature organization with well-integrated security fabric will follow most of the steps that you see here. Security requirements would get drafted into SRS. Design stage focuses on threat modeling and security features that need to be built. Development stage would focus on security code review as a combination of manual and automated mechanisms. The development cycles were long, typically just like Derek mentioned, and it was easy to integrate the security code review in a semi-automated fashion. The deployment was done by a separate team, and things like DAST or Dynamic Application Security Testing, the infrastructure being security tested, all of that happened typically by a different team for operations. And SDLC, essentially, SDLC security in Waterfall world laid a lot of emphasis on security to be visible and traceable. For example, did security design match with the SRS cases, match with coding guidelines? Did the security features built, finally match back to the SRS? So there were a lot of checks and balances. It was visible, traceable. But the key insight is that the better we shifted to the left side of this picture, the more secure the code is. Fast forwarding from there on to the new world of DevOps, it's a very different world. The key change is that it's not a linear world anymore, just like how the Waterfall was. It's more cyclical. Stages we see here happen quickly and continuously. How quickly depends on the agile methodology that is followed. So a software build can happen within a few hours to a fortnight. Trying to overlap Waterfall methodology, security mechanisms here will fail due to a number of reasons. The speed is inherently different here. It's a very dynamic, continuous and incremental model as against a largely static model in the Waterfall world. And in this world of DevOps, change happens to be the only constant. Therefore, the critical success factors for DevSecOps, these were some things that we felt are critical. The security practices that we follow in DevOps, or when you add security into DevOps, DevSecOps, should adapt to the continuous incremental nature of DevOps. Security definitely needs to keep pace with the build and deployment cycles. Security code reviews, as an example, can only be a fraction of the build cycle time. Given that developers are super focused on speed and functionality and business value in DevOps, as far as possible, security should be an invisible layer for developers. It shouldn't become something that is overtly visible and comes in the way of speed of development. So we essentially need to move from a siloed mechanism to a continuous model. We need to do a lot more automated mechanisms in DevSecOps and move from the visible and traceable security model that was there in Waterfall to as far as possible an invisible layer for developers, but with tangible output coming into picture. Security objectives are also different in the DevOps world. In the DevOps model, operating a secure infrastructure and therefore protecting customer or organization IP is an inherent part of the model. It's very closely aligned to cloud. So infrastructure security often means cloud infrastructure here, or it could mean a hybrid kind of infrastructure. And the responsibility for securing the operations usually is not a completely segregated responsibility like in the Waterfall world. it's part of the same DevOps team. So apart from continuous detection and remediation of code-related vulnerabilities, DevSecOps teams are also tasked with detecting and remediating vulnerabilities in the cloud infrastructure and also monitoring these systems for attacks and security threats that are happening. So security across the CI/CD is often different from Waterfall. So this is an overlay of security activities in the CI/CD model. The black dotted rectangles refer to security activities. Design is an inherent part and needs to be factored in as part of the product vision. Threat modeling needs to be done continuously as part of the product backlog, sprint backlog cycles. Leading organizations have also started adopting security spell checks or checking for insecure code in real time as developers do the coding and provide required training also on the fly instead of it being a separate mechanism for training security practices into developers. The SAST or the static application security testing needs to have a continuous model. We'll see that in a few slides. Similarly, the DAST, config, audit, scanning, monitoring for the infrastructure that gets pushed out to the cloud are all integrated into a continuous delivery phase. So the model, as you can see here, the activities look similar. We still talk about security design, threat modeling, code reviews, etc. But the key difference is the way it gets integrated into the DevOps cycles. So we'll take a look at how each of these phases blends into the DevOps cycle. So security design remains a static activity even in a dynamic DevOps world. Things like designing for secure authentication or authorization or encryption, etc. Once done thoroughly will sustain across the many build cycles, but getting it right at the product emission stage becomes important. Threat modeling, on the other hand, has to be part of DevOps fabric to make sure that critical risks are not missed out. And the model, again, looking back at what Derek had presented, it's more about business value. So therefore, threat modeling has to start looking at identifying the business risks, and then you try to break down the application components into infrastructure, app platform, code. Look at different threat actors who can potentially come after your organization and therefore identify the threats at these different levels of infrastructure, app platform or application code. And then when we say identify threats, of course, identifying the vulnerabilities inherent in those threats is default. And then identify what are the security user stories that we want to push into the build cycle. So if you take a quick example of an e-commerce application, the business risk can be a card theft scenario or theft of personally identified information. Application components could be, Linux OS, Apache, web server, Oracle. Application platform can be Struts, MVC, the code written in Java. The threat actor can be typically a cybercrime syndicate, coming after financial gain. The threats, the one on Apache Struts is now very well known. Possible remote code execution using REST plugin. On the code side, it could be a card data theft can happen through a SQL injection to extract those details, or it could be a command injection, file inclusion attack. There are many ways to do it. And if you try to map that back into a security user story for the Java code side of it, to protect against it, we would need input sanitization for injection attacks, could be prepared statements, input validation for file inclusion attacks, etc. So the threat modeling has to be a continuous activity, but it has to start from looking at the business risk and end up on whatever is the proper security user story that needs to be laid out in terms of feature sets. On the mechanism to integrate threat modeling, Usually the vulnerability analysts are inherent part of the stand-up meetings, or they can be involved at specific triggers around the sprint planning or grooming cycles. The next phase is possibly the core phase of the DevOps model. The code reviews have to be continuous and invisible to the developers. So in this model, for example, as the developers push the code for build, the code scan is initiated and the defects are raised in the same defect tracking system as the developer is using for tracking normal defects. And the code review checks are aligned with the threat models and security user stories. We use MicroFocus Fortify as a technology for all of our code reviews. So James will cover the key features and differentiation of Fortify in the next session. Code reviews also need to benchmark with best practices. So in our methodology, we benchmark all the categories of checks with OWASP, WASC, and SANS. The next few slides essentially capture the categories of checks and the mapping in these standards. You can go through these since the session recording will be available. I'm not getting into the details in the interest of time. So all these are different, categories of checks in a secure code review and how they map back into these best practice standards. So in terms of the pre-production and production deployment, it is inherent that the integration into the different cloud and automation fabric has to come into picture. So as an example, the infrastructure scanning that happens needs to be integrated with automation platforms like Chef, so that when the dynamic workloads are created, they can be scanned on demand. Similarly, DAST kind of scans can be triggered for at least the specific use cases as soon as the code gets pushed into production. So the pre-production and production, it's very critical that it is properly integrated into the cloud and automation fabric that is part of the DevSecOps world. The more critical angle in terms of production is, given that you can detect so many different vulnerabilities, it is impossible, given the speed at which DevSecOps moves, to actually fix all of these. So at some point, we need to really prioritize which ones we are fixing. So this is an example of a triaging model that looks at different parameters. Some of the key parameters are, looking at vulnerability intelligence, which basically means that how do we understand what vulnerabilities the attackers are going after. So one metric is which CVEs are seen in these exploit kits. So being able to identify those CVEs and prioritize them for fixing. Similarly, if you have security operations, we can identify what is the higher volume of attack targeting. So if they are targeting specific attacks on globally or onto your infrastructure, those vulnerabilities can be prioritized higher for fixing. So vulnerability remediation becomes critical, but there the prioritization part becomes very important. Here is a quick summary of the delivery model for integrating security into the CI/CD model. So the left side is all the services part, different services that gets offered as part of the delivery model. We use a combination of technologies. So RiskView there is the delivery platform of Paladion. It integrates into MicroFocus, which is the tool that we use, MicroFocus Fortify. And of course, on the right side, you see the skill sets that are required, irrespective of the technologies or the automation. You still need the skill sets to come in terms of the threat modeling, in terms of recalibrating the false positives, in terms of identifying the key prioritized vulnerabilities to act on. Having said that, it also becomes important in terms of monitoring for threats, because DevSecOps really means operationalizing the build that has happened. Paladion also provides managed detection and response for monitoring the production DevSecOps environment. The model that you see here is essentially for detection as well as for response, with a combination of big data, advanced analytics with machine learning. The faster response, of course, happens through security orchestration mechanisms. Last but not the least, the production security monitoring also needs to pretty much integrate into the the DevSecOps fabric, which is essentially the combination of cloud technologies as well as technologies for automation like Chef, Ansible, Puppet, etc. And very similar to the security testing mechanisms, the production security monitoring also needs to be on demand, be able to scale up, scale down based on the workloads that gets initiated. So with that, I will hand over to James, and thank you so much for participating in this this session. James, I'll hand it over to you now.
Thank you very much. So I am James Rabon. I'm a Fortify Product Manager. Let's go ahead and let's talk a little bit about what we're going to cover. I'll give a brief overview of our application security portfolio. We'll go through some of the keys to supporting DevOps. That'll be mainly focused from a static analysis perspective. Most of the things we'll cover today are more from a static analysis perspective as far as integrating static testing tools into the software development lifecycle, specifically around DevOps. We will cover static analysis testing in the forms of Static Code Analyzer, Software Security Center, Audit Assistant, and some of the other products that help enable and building security into the SDLC. We'll go through some of my tips around best practices for integrating secure DevOps, and we will look at some actual examples for the secure DevOps reference architecture. All right, is everybody able to hear me? Everybody can hear me just fine?
Yes, James, it's fine. Yeah.
Okay, thanks. All right. So let's go in here. So looking at kind of our overall portfolio of solutions for application security, you can see static code analysis, or SAST, is in the kind of the leftmost leaning part of the software development lifecycle. We also have some lighter weight technologies in SAST as well that are IDE and real-time specific based that we'll focus on today as far as DevOps goes. Let's see, the web inspect on the dynamic side is a little bit later in the life cycle. Obviously, when you have an application that is deployed in either testing or staging environments, and then real-time protection comes even later on the production side. We also offer a managed service that provides all of these in the cloud if you'd like to outsource that. So let's go ahead and go to the next slide. So what is DevOps? As we kind of look at the version control to build, to testing, to deployment, the automation around that. Go ahead and send this. The source code management is obviously a part, so security testing tools have to be able to get the source code that we're going to be analyzing. Obviously, really important to get the source code, but also the matching dependencies. Various applications use various languages and frameworks that have to be understood in order to provide quality analysis. Build systems, compile, and continuous integration systems like Jenkins or Bamboo, automate and build these applications, and providing easy integration into those systems is obviously key. If we go ahead and look at, go ahead and advance it forward, from a testing perspective, and then from a provisioning and deployment perspective in terms of the kind of explosion of these orchestration tools in terms of Chef or Puppet that automate and deploy and build out these complex development environments. So in terms of the technologies that we typically, when someone says that they're leveraging a DevOps methodology, or they're hyper agile, or whatever the case may be, they often, there's varying degrees of that, but it almost always means that they're leveraging these 4 kind of key areas of tools, and that we're going to have to, from a security perspective, integrate into those. If we go ahead and advance through, we can. So just a quick look at SCA. What we're doing is our goal is to be the most comprehensive static analysis tool while at the same time being easy to use, providing out-of-the-box support for build integration, and most importantly, scale. When you talk about integrating security tools into the DevOps tool chain or any kind of very efficient application development lifecycle, the key is to be able to support all manner of applications. So we need capabilities to scan the largest of enterprise systems or operating systems that are millions upon millions of lines of code, all the way down to providing the ease of use that you would expect for even smaller applications and kind of anything in between. If we look at our Software Security Center, this is our web application that consumes security results across the lifecycle, and we'll show you in the reference architecture how that works. But essentially, as you're running these automated static analysis scans, you need to be able to save the comments, you need to be able to save the audit decisions, you need to be able to merge those and track those vulnerabilities over time. You also need a place to consolidate results before you pipe that into different communication channels that are going to vary from team to team in terms of the DevOps landscape. So in terms of defect tracking systems, in terms of chat ops, wherever is the most effective place to communicate with developers, uploading results in our solution to Software Security Center provides this kind of a staging environment to then spider that data out to wherever the most effective place is to communicate with developers. That's something I've really seen as a change as I've been doing this for a number of years. And oftentimes, specifically in DevOps, developers or customers don't even want a portal, another portal or another new technology they have to learn or learn how to use or the interface. They want the information streamed directly into the communication channel they're already using. So many of our customers, may even obfuscate Software Security Center behind the scenes where it does all the nice things it does is providing a collaboration module and merging and tracking of issues over time. But they're actually piping all those results into a defect tracking system to communicate to developers, or they're streaming that into even to an instant messaging client if that's the way they communicate. If we go forth in terms of integration, so the biggest challenge that I face, as a product manager and a security tool, is the enormous complexity of the DevOps tool chain or tool stack. You can just see here. Here's a number of different continuous integration platforms, IDEs, defect tracking systems, build tools, and so what kind of our goal and my goal is to provide out-of-the-box support for the market leaders in all of these areas. So, for example, an Eclipse, an IntelliJ, and a Visual Studio, we're obviously going to have out-of-the-box support for IDE plugins for those tools. Jenkins and Bamboo being kind of market leaders, or Circle CI, we're going to have continuous integration plugins out of the box that make it really easy to add our tools to those platforms. But what we're going to do is at the same time, we're going to make sure that we are sharing that code for those integrations, that we have a plugin framework that's easier to use, that is easy to use, and that we have extensible and well-documented APIs to enable the supported building of custom integrations because there's just no way that any one provider can provide an integration into every tool, given the market presence of some, or the relatively homegrown tools, or just niche continuous integration tools that don't have quite enough market presence to warrant prioritizing building a plugin for them. So really, when you look at the ecosystem, it's about providing coverage for those and samples and integrations, but really enabling customers to really treat their infrastructure as code, which is one of kind of the tenet principles of DevOps, to do those integrations for themselves. If we go forward. We provide tools that fit into the IDE. Security Assistant in particular is our static analysis portfolio or static analysis tool, SPA, is designed at false negative is the worst thing in the world. It's designed to find and do deep dive data flow analysis to find the most comprehensive and accurate security vulnerabilities. Security Assistant is flipping the script a bit specifically for the DevOps movement, where we provide in real time as you type, security vulnerability assistance in IDEs. We released this for our Eclipse IDE. We have a number of other IDEs in planning, but this is actually a continuous assessment while a developer types code of a subset of the issues that we can find with static analysis that occur in less than a second and are very lightweight. And in terms of continuously validating security or quality, which is a tenet of DevOps, we're finding that security assistant-like tools that still do, complex structural and semantic and within a single class or intra-class data flow are necessary. I'm not talking about just pattern matching or basics, but lightweight, real, static analysis in the IDE is really where we see a lot of future in terms of finding vulnerabilities before the code is actually even checked in to a code repository and becomes something that you have to find as part of the build. If we look at Security Assistant here, you can see just showing off of some of the features, issues that we detect in real time, and then the details and recommendations how to fix those issues. All right. I mentioned extensibility being a key part. Obviously, making that code available to customers is paramount. What we've done is we created a sandbox utility that basically, as customer requests come in for various scenarios, we go ahead and write samples of that using our JavaScript sandbox project so that customers have an easy reference point and can go ahead and have an easier time leveraging the APIs. Not enough to just provide documentation. We have a self-documenting API using Swagger, but you really do need to provide coding samples and examples of how to do your most basic activities and key activities with your APIs if you want customers to really extend it into the full value. We also have kind of a mantra in this world of open sourcing our plugins that we build so that potentially customers could update them or create their own, they could port them and create their own version of the plugin, but also to provide a sample, right, to enable them to build their own if they need to. All right, if we go ahead, let me go ahead and advance this forward. So with Audit Assistant, one thing I haven't specifically mentioned, is specifically the time it takes to triage static analysis. That is, without a doubt, the #1 time-consuming activity in integrating static analysis into a rapid application development process, irregardless of what it is the time to triage. So what we've done is we have built a machine learning capability that essentially takes static analysis results. We fingerprint those issues, and then we send that to our repository we have of audit decisions that we've made in our managed service of issues of that same type. And then we're able to give you a prediction back based on actual human, application security subject matter expert opinions of similar types of issues and how those individuals triage and put those assessments on those issues. So, traditionally in static analysis, you have impact or likelihood or some mixture of the two in terms of a mathematical computation to give the customer some type of understanding of the impact it could have or the likelihood of exploit. And Audit Assistant is actually a third piece of data that shows you whether someone, a real security auditor, has marked something as true positive or not an issue. And what that's enabling as the technology improves is the potential to actually automate auditing, which you can use our audit decisions that we've made, which are non-contextual based decisions, so they're technical decisions, or you can leverage your own audit decisions and train your own algorithms with your own context-based decisions for your own application, and then leverage that going forward to automate either applying of an audit decision or just using that prediction to know what to focus on. Here with Audit Assistant, we have static analysis results. We audit those issues. Go ahead and advance it. And we fingerprint the issues and anonymize that data. Things like what type of issue it is, what is the data flow, how many inputs, how many branches. We send that to our back end, and we actually provide you a prediction back end, a specific mathematical confidence value. That enables you to do all kinds of interesting things in terms of a kind of an advanced DevOps type workflow with static analysis tools. So we'll show you, I'll obviously show you an example of that, and we'll be kind of putting all of these products together to create a really highly efficient workflow. So let me go ahead and advance to read this, and we can focus on what counts and correct anything that's wrong, and that's really the key, right, in machine learning. If you give us good data, we provide you good predictions. You can accelerate DevOps, you can remediate faster, and you can take the knowledge of few and apply that to many, right? Very efficient. All right, so some of the best practices for integrating security with DevOps that I found, making security be seen as something part of it as a value, right? Any security findings that we're able to identify, fix, right? That's a value. That's saving us time where we don't have to go and fix that in production later. I always try to look for skilled early adopters. So there's always pockets in any enterprise, especially in larger enterprises. There's going to be pockets and different, skill sets amongst teams, and trying to find people who are interested in kind of new technology and are highly skilled and willing to help really fold the tools into their process. And those are kind of your best bets for integrating that into. Working in small consumable steps. Standardizing on a tool set is certainly key. The more varied your ecosystem of tools are throughout your enterprise, the more challenging it is to create the type of efficiency workflows that we want to do with DevOps. If you have 5 different bug tracking solutions, if you have multiple continuous integration platforms, it's going to be more work, right? There's no way around that. There are things you can do in terms of abstraction and things of creating a service around that, but it's really a lot easier if you can kind of standardize on a set of tools for an enterprise. Focus on the wins. I usually like to focus on specific types of vulnerabilities when starting an application security program. Cross-site tripping, SQL injection, things I know are remotely exploitable. Those, issues of which I know the remediation effort is minimal, where we can get some of those quick, visible wins. Definitely focus more on the process and focus on what you fix as opposed to defect totals. Anyone can scan lots of code and find lots of issues, right? Really what you're measured on is what you fix. Begin with a very loose security policy, and you can tighten that as the process matures. One kind of pitfall I'll hopefully help you avoid is marking builds as failures for any type of static analysis finding. It's common for people kind of familiar with DevOps or those type of processes to ask about failing a build. I have no problem with marking a build as unstable or even failing a build, but that's the maturity level that has to occur that I'll explain in the next example. You're just going to end up with a lot of broken builds if you fail based on, and you don't set your confidence threshold, and you don't narrow the issues that you're looking for, and you don't compensate for issues that are known, right, as opposed to new issues. Those are all kind of key things you have to do in terms of failing a build or marking it unstable based on a tool that is run automatically. Okay, as we progress forward, so here's kind of a high-level example. I try to make it as generic as possible so that hopefully you guys can use it in some fashion. So step one, we have some kind of build or translation. That's typically orchestrated from a CI platform. Our tools easily integrate with all of the major build tools, and we have plugins for Jenkins and other CI systems to make it really easy to add a security scan as part of the build. The nice thing is you have all of the dependencies and everything you need already configured, so automating that is step one. I like to set up a cluster of scanning machines, meaning that something that is scalable, something that has queuing available, so that I can simply add additional static analysis engines to an additional machine if I need to scale up, or the enterprise needs to grow over time. So kind of starting with a scalable pool of available machines, and we provide out-of-the-box technology to help you set that up. Once the scan results, we go ahead and upload that automatically to Software Security Center. We have tools to make that very easy. So the upload happens, but the key here is that we are merging the new scan with any previous scan. So any previous audit decisions, any previous comments, any previous suppression, any filters, any kind of thing that has been done in the past of a known issue is kept and tracked over time. And that's really key. In this example, we automatically go ahead and request a prediction from Audit Assistant. So we're going to get impact and likelihood with static analysis. We're going to get our prediction back based on human being decisions in similar situations. In step 4, what I like to do is to go ahead and alert, typically in Jenkins, if any kind of new issue that's not already known is found, go ahead and either mark the build as unstable or send an email to let a lead developer know that a new issue has popped up and one that meets the threshold for it being worth a lead developer's time to go look at. Right? So let's say we determined critical issues which have a high impact and high likelihood and are predicted, right, to be true positives. We would go ahead and go ahead and mark that as unstable. Then the lead developer can triage that and go ahead and assign that to a defect tracking system. We support 5 major bug tracking integrations out of the box. We provide bug state management in terms of closing defects automatically. Go ahead and move that into the ticketing system to share this issue with the developer. And then the developer can look at the results in their IDE plugin. They have the local security assistant real-time scan as they develop code, but they've got the full results of the entire application and any issues that they're required to fix. They simply fix the issue and check the code back in. So that's kind of an example of an efficient workflow that would work for many systems. And I know my own development team, we operate in a similar fashion where the best way to communicate with my team is through Bugzilla. Therefore, any security defects that we find are certainly communicated through there. All right. I think I have, hopefully I'll pass it back over. That's all I have today. Thank you.
Thank you, speakers, for those valuable insights on DevSecOps. Unfortunately, we don't have time for a Q&A session. We did get a couple of questions. We will try to answer those privately. Just as a reminder, you can download this presentation from attachments, and all registrants will receive a copy of the ebook and the recorded webcast in a few days. Thank you for attending and have a great day. You may now disconnect.